Okay, something you may or may not have seen before is solving equations that are not quadratic equations, but solving them like they are quadratic equations. We call this solving equations in quadratic form. So we can do this by factoring. For example, x to the fourth minus 7x squared plus 12 equals 0. Well, this is not quadratic because our highest exponent is 4. But you could recognize that x to the fourth, which is that first term, is equal to x squared squared, and the x squared part is in that middle term. That's important because then I can substitute a variable. Let's choose any letter you want. Y, U. I'm going to use U here. And say that U is equal to x squared. It's actually that middle term, the variable part of that middle term. Then U squared is equal to x to the fourth. Now, I'm going to substitute into my original equation. So x to the fourth becomes U squared. Minus 7x squared becomes minus 7u. The plus 12 equals 0 remains the same. Okay, now this equation, u squared minus 7u plus 12 equals 0, is a normal quadratic equation. We're going to solve this by factoring. The left-hand side factors to u minus 3 times u minus 4. We have 0 on the right-hand side. Use your zero product property. U minus 3 equals 0, or u minus 4 equals 0. So u equals 3, or u equals 4. Okay, but we're not done because our original equation has x's. So we need to substitute back. What does u equal? U equals x squared. So we have x squared equals 3, or x squared equals 4. And now we need to solve both of those equations. So the first one becomes x equals plus or minus radical 3, or x equals plus or minus 2. I actually have 4 solutions for this example. And this exponent here, the highest exponent in the equation, indicates usually the maximum number of real solutions that an equation can have. We have an exponent of 4, means we could have 4 real solutions, and we actually do in this case. Okay, let's look at another example we can solve this way. This one looks even more different. So I have 3x plus 1 quantity squared plus 3 times the quantity 3x plus 1 plus 2 equals 0. Now you might be tempted to kind of expand this out and simplify it, but then it will probably become harder to even solve. I'm going to recognize right here that I have 3x plus 1 and 3x plus 1 squared. So let u equal 3x plus 1. So u squared will equal, 3x plus 1 quantity squared equals u squared, plus 3 times 3x plus 1 equals plus 3u, plus 2 equals 0. This factors, u plus 2 times u plus 1 equals 0. Zero product property, so u plus 2 equals 0, or u plus 1 equals 0. U equals negative 2, or u equals negative 1. But remember, we're not done. You need to substitute back in. So the first equation becomes 3x plus 1 equals negative 2, or 3x plus 1 equals negative 1. And now we need to solve both of these equations for x. 3x equals negative 3, or x equals negative 1. 3x equals negative 2, or x equals negative 2/3. So I have x equals negative 1, or negative 2/3. Okay, try this. Solve 2x to the 6th minus x cubed minus 1 equals 0. Use the type of method that we just did, solving this in quadratic form. Pause this while you try to solve it, and then start it up again to check your answer. Okay, here you should recognize that x to the 6 equals x cubed squared. So I'm going to let my u equal x cubed. Means u squared equals x to the 6. So my equation becomes 2u squared minus u minus 1 equals 0. This factors to 2u plus 1 times u minus 1 equals 0. Zero product property makes this become 2u plus 1 equals 0, or u minus 1 equals 0. So 2u equals negative 1, or u equals negative 1/2. U equals 1. And now I need to substitute back in that using u equals x cubed. So I have x cubed equals negative 1/2, or x cubed equals 1. Take the cube root of both sides. X equals the cube root of negative 1/2, or x equals the cube root of 1, which is actually 1. So I've got two answers. X is equal to the cube root of negative 1/2, or 1. Okay, we can solve quadratic form problems not only using factoring, but also using the quadratic formula. For example, 2x to the 10th minus x to the 5th minus 4 equals 0. Okay, so I've got my x to the 10th, my x to the 5th. So recognize that x to the 10th equals x to the 5th squared. So my u will equal x to the 5th, the part that was squared. Okay, so that means u squared is equal to x to the 10th. Now let's substitute in. So I get 2u squared minus u minus 4 equals 0. And now we're going to solve this using the quadratic formula. So our a is 2, b is negative 1, c is negative 4. So u equals the opposite of negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 4 all over 2 times 2. Okay, u equals 1 plus or minus the square root of 1 plus 32 over 4. U equals 1 plus or minus the square root of 33 over 4. And this becomes two answers. I break it down into the plus and the minus one. And now I can actually compute an approximate decimal. So the first one, u equals 1 plus radical 33 over 4, becomes u is approximately equal to 1.69. And the second one, u equals 1 minus the square root of 33 over 4, becomes u is approximately equal to negative 1.19. Okay, from here, we will substitute back in. Remember, u is equal to x to the 5th. So x to the 5th is approximately equal to 1.69. Or x to the 5th is approximately equal to negative 1.19. Use your calculator to take the fifth root of both sides. X is approximately equal to 1.11 or negative 1.03.